Hi, it's Dr. Pat. I'm looking at quiz number 4. We'll start with question number 1. We have two functions here. We have the function f function, and then right here, and then we've got the g function. And what we're looking for is we're looking for the region in between. So this region right in here between the two graphs. So there's f. There's G, and we're rotating it around this axis here of y equals 15. So our first question is can we use discs, washers, tubes, or shells on this one? Which one's the most effective? The easiest in a way. Discs are out of the question because we have this space in between here. The space in here means that discs are not a possibility. The space between the region and the axes of rotation, if you have space, we can't use discs that way. And then what I'm looking at here is the other possibility is washers. Now washers look nice here because a washer would be using this vertical distance between the two graphs rotated around the things. We have a distance between the two graphs here, and then we have the region. So we have an inner and outer function to create the washer. So that's looking good. And because I drew a vertical line right here, I will be using a dx. It's a dx situation. So I want to use a washer with a dx situation because I'm drawing vertical lines for making my washer. All right. So for the formula for doing washers, we're going to have a pi out here factored out, and then we're going to have r squared, the outer radius minus the inner radius. And since I'm calling it a dx situation, I got to add my dx there. So r squared minus r squared, the outer minus the inner. And when putting this into the formula, got to be thinking of what my capital R here. Since we're rotating around this horizontal line of 15, it's going to be 15 minus the function. And so r, the farther one, is going to be using the g function, so it's minus the g function. So that would be 15 minus x squared. And then because I'm minusing a negative 4, it'll turn out to be plus 4. And so that turns out to be a nice 19 minus x squared. So there's our formula for capital R, the outer radius. The inner radius, it's going to be 15 again minus the f function, whatever the y values are for those. And the f function there is that straight line. So we're going to be looking at 15 minus, that's 4 minus 2x, so that'd be minus 4 plus 2x. And simplifying that one, if you'd like, would be 11 minus 2x. So there's our radiuses for the two things. So let's go over here to the formula and type them in. And so our volume is going to be the integral. And since I'm using dx's, I'll be using the x value of that intercept right there and the second x value of the second intercept. And from the graph, we were able to see that that would be negative 4 to 2. So from that graph was given on the quiz itself. That's how I got those. And then putting in my values for my radiuses, I've got 19 minus x squared, quantity squared, minus 11 minus 2x, quantity squared, dx. And that's how I would do this using washers for doing this problem. Now, if you thought maybe we could have done tubes, you can use tubes for this one. I would not call it the most effective method. The reason, if we're going to use tubes on this, is that you would then, for tubes, draw a horizontal line. There's a problem with when you draw that horizontal line for the parabola part, you're using the parabola twice there. And so what you're doing is you're separating the region into two parts of the region. So what you have to do is you've got the bottom part where you're going from on the right hand side over here, you're using the right side of the parabola to the left side of the parabola. And that will be one set for the integral. And then for the top half of this region, then we have the nice straightforward distance between the two graphs. So if you wanted to use this, we would have to set it up as two integrals going from 0 to 12. It's a dy situation as well. So if we're using shells, tubes or shells, in this case, it's going to be a dy because I'm drawing horizontal lines, and the thickness is a dy idea. And so that's why I'm seeing a 0 to 12. I'm using my y value. We have a 2 pi in the formula for our shells. And then we have an r value. In this case, the r is going to be 15 minus y all the way across, all the way through this region. Just the r value is the distance from the line 15 that we would have. And then we would have right function minus left function. Since I'm doing a dy situation, it's right function minus left one. And then you're going to have to take each of the functions and solve them for y. And so that's why I'm going to be seeing this 4 minus y over 2, and then minus a negative square root of y plus 4. Since I'm using the left side of the parabola when I solve for that, I have the negative version of that. And of course I'm doing a dy for that. And then plus, well, that was the top part of it. Now the bottom part, I'm sorry, I just wrote it wrong that way. I've got my 2 pi. We can put that inside or outside the integral, doesn't matter. We're going from negative 4 to 0 for the bottom part. The very bottom of the parabola is at negative 4, and then the transition area we have is 0. And so once again, the radius, the distance from the region to the axis of rotation is 15 minus y. And then what I've got here is I'm going to double up, because basically it's going to be the square root minus the negative square root. So it's going to double up. That's the part of the function, the parabola, solved for in terms of y. And so there we go there, and dy. And so that's how I would use it for shells. So we have washers or shells. Clearly the washer is the most effective way because we're only dealing with one integral. Thanks. I hope this helped. Talk to you later.